Going to be talking about question number 12 up to number 19. Let's get started. So here we have trying to find the concavity and also point of inflection. To find that, what we like to do is maybe we'll find the first derivative first. Then using the quotient rule, the denominator will be squared, and we have 2x, which is the derivative of the top, and then 1 plus x squared minus also 2x, which is the derivative of the bottom, and x squared minus 1. Now, but notice that the 2x is common, so when you factor them out, we have 1 plus x squared from the first term minus x squared plus 1 from the second term, and 1 plus x squared, entire thing squared. Here, these two things cancels out, so what we end up getting is 4. 2 here, and then 2 here, 4x all over 1 plus x squared squared. Now, an f double prime, once again, has to be done with the quotient rule here. So we have 1 plus x squared to the 4th power, and once again top is 4 times 1 plus x squared squared minus, now 4x is already there, derivative of the bottom becomes 2, comes out, and we have 1 plus x squared times the derivative of the inside, which is simply 2x. Now, when we get to realize there are a few things that are common factor between these two, which is 4, and then 1 plus x squared is common. That means from the first one we have one other 1 plus x squared is left. Now, when you look into this one, you will realize that 4, and then this one has been taken out, so what's left is x times 2 times x, 2 times x. So what we end up having is negative 4x squared, and divide entire thing by 1 plus x squared pointing to the 4th power. But as you can see, this factor and then this factor becomes 3 are common, so therefore there it goes. We have 4 times 1 minus 3 x squared all over 1 plus x squared to the 3rd power. Now, when will second derivative be equal to 0? Or not defined for that matter. I mean, it will always be defined because the denominator here becomes is positive at all values. Only thing which we have to worry about is the numerator being 0, but 4 is never equal to 0, so we could have said 1 minus 3x squared can be equal to 0. Now, when you solve this one, we will realize x must be equal to plus or minus square root of 1/3. All right. Now, then we have to try for number line. So to the number line we have, here it becomes negative square root of 1/3, and this is positive square root of 1/3. Obviously, the value which we can check upon, here becomes x equals 0. And then here maybe we'll do x equals, oops, it's not 3, but in fact 1/3, which makes I can test x equals 1, here x equals negative 1. Now we just have to test this upon the second derivative, which is this portion right over here. So once you plug in negative 1, we get the upper portion becomes negative, while denominator is positive, so here is negative. Once you plug in 0, everything will cancel out except 4 over 1, which is positive. How about here? When x equals 1, in fact, you're going to get the same result as when x equals -1, through the negative sign. So here, let's try to write it down. Concave up. Concave up is from here to here, so we're going to write it as negative square root of 1/3 all the way to square root of 1/3. Alright, concave down actually has two locations, negative infinity to negative radical 1/3, or radical 1/3 to positive infinity. That becomes our intervals where concavity is negative. Now, point of inflection. That's where concavity changes. So x values for that becomes negative square root of 1/3 and positive square root of 1/3. Now, but in order for you to find the y value, because that's what they're asking for regarding coordinates, so once you plug in those values into here, so we get, for example, negative 1/3, a square root of 1/3, square minus 1, over 1 plus negative square root of 1 over 3 square. Here we'll end up getting 1/3 minus 1, and on the bottom 1 plus 1/3. That's what we end up getting, and which is 2/3, but negative. On the bottom we get 4/3, which basically translates to negative 1/2. Now, so in fact we will end up getting negative 1/2. Well, once we plug in the square root of 1/3, it's not going to make any difference between these two. Therefore, this will be exactly the same, which we have negative 1/2. That becomes our answer for the first one. Now let's look at the second question. This is also a great question, because once you take the first derivative, this becomes 3 minus 1/3 x to the negative 2/3 power. Now the second derivative, here it becomes 0, and then here now becomes 2 over 9. And then x to the negative 5th over 3 power. Now, once again we have to set this one equal to 0. We get to or undefined, or do not exist. But if you have to rewrite this one, what we end up getting is this 2 over 9, and then cube root of x to the 5th power. Now simply, this will never be equal to 0, but it can be not equal to, not be defined when x equals 0. Now, then using a number line, and then let us try to look, let x equals maybe 1. When x equals 1, we realize that this one is equal to positive. And the second derivative is positive. And then when x equals negative 1, the second derivative becomes negative because of the odd exponents. So therefore, places intervals where concave up is the right side, where 0 through positive infinity. Concave down is simply from negative infinity to 0. Now, point of inflection, basically where concavity changes is when x equals 0. But when x equals 0, when you plug in here, y is also equal to 0. So 0, 0. There it goes. Number 13. Number 14. Let us try to take the double derivative in this case, just like the other two questions. First derivative becomes 15 x to the fourth minus 15x squared, and 1 becomes 0. Now, once you take the double derivative, then we end up getting 60x to the third power minus 30x. And if you have to rewrite this one thing that we get to realize is 30. X is common, then we have 2x squared minus 1. Now, here we have three values here. Because of the first one, we get x can be equal to 0. Here, x can be positive or negative. 1 over square root of 2. Alright. Then using a number line, we have 0. We have positive 1 over square root of 2. The other one is negative 1 over square root of 2. Now, how do you know which interval is positive and which interval is negative? One easy way which you can do it is this. Look at the second derivative, because these values will be all evaluated against the second derivative. You have a cubic function. Cubic function simply means the functions go this way or this way. Now, since the leading coefficient is positive, our answer will be this. In other words, as it passes through 3 times, it's going to be something like this. Right? So then we have positive here because those are all of the x-axis, negative here, negative here. So concave up is from negative 1 over square root of 2 to 0, or 1 over square root of 2 to infinity. Alright, next part, concave down. Negative concavity is negative infinity to negative 1 over radical 2, or 0 through 1 over radical 2. And point of inflection. Point of inflection seems to be where concavity changes. That means all 3 points seems to be the answer. Alright, so here comes number 15. Function is decreasing. Function is decreasing here, that means f prime has to be negative. Where do we see negative? From here to here. That means from 0 through 3. 0 through 3 will be, only choice will be choice number C. Alright, Alright, so let's look at number 16 here together. So when you look into this one, the graph is going down. That means f prime has to be negative. And then also concavity is negative. That means f double prime also has to be negative. Now, let's look into this question. F is decreasing, which is true, and C and D will not be the answer. Now, how did f is decreasing at what rate? Now, rate here implies the first derivative. But as you can see, second derivative is also negative. That means it has been decreasing rate. This is the decreasing is the derivative of derivative, and decreasing means negative. So therefore, our answer will be choice B. Now, here we have the graph here is increasing, now decreasing, increasing, and decreasing. So basically what we're looking for here is taking the derivative of this function. So let's try to do that. And f prime here is equal to 3x squared plus 12. Now, then when you set this one equal to 0, we get to realize that we have in fact, in this case, this will always be positive because the lowest value where x squared can be is 0, and then with the plus 12, this will always be positive. So that means increasing at all real values of x right here. That would be our answer because f prime is always positive. All right, number 18. Now, this is the derivative, as you can see. Which one of the following could be the function of f? Now, that means from first derivative to original graph, what we have to look for is a couple of things. For example, this point is very important because this is a place where we're going to have positive to negative, meaning relative maximum. So when x equals 2, we got to have relative maximum, which will be possibly A, not C, not B, B because we have relative minimum, here relative minimum, and, oh well, only thing that's possible is choice A. Alright, let us continue to look at the next question. Here we have which function, which of the following are true about function g, where this is g prime. Now, function is increasing for x is greater than or equal to 2. So greater than or equal to 2, g prime is positive. When g prime is positive, then yeah, g is increasing. That is correct. Now, function g has 4 points of the non-differentiabilities. Now, if it's not differentiable, then we wouldn't be able to have g prime, but it seems to be we got the sum of g prime on all locations. So therefore, second one is false. Now, number 3, the retrieved function g is not continuous function. In fact, if it's not continuous, then we wouldn't be able to take the derivative anyway. So only possible answer is 1 only, which is choice C. All right. So with this, we are finishing up part 2. Have a nice day. Bye bye.